Hello everyone, I'm Xia Chengshuo, a second-year PhD student from Keio University. Today, I would like to give the presentation named Personal Identification Using Gen Data on Sleeper Device with Accelerometer. As we all know, nowadays the personal identification becomes very significant, especially in indoors facilities. It can help us to understand the facility usage status and reduce the burden on staff and users. There are several different types of personal identification. The common methods are knowledge and property-based. It will face the risk of leakage and theft. The biometric-based method changes the traditional method. For physical biometrics, it uses the user's face and appearance for identification, but increases the additional actions, such as looking and touching. While the behavioral biometric realizes the identification through the daily activity, and the burden on user is small. So, in this paper, we use the walking data to identify the user. The walking movement is detected by the wearable device, Sleeper, which is very good at privacy protection and very common, so it does not invade the user's daily life. We built our system based on the machine learning system. The features were extracted from users' walking data and used to train the SVM classifier, and finally, it is used to predict the identification result of the user. We adopted the frequency domain data. After segmented the walking data with a specific window, we calculated the FFT result and cut out only half quantity, and then used them to train the classifier. We applied totally 6 accelerometers on one sleeper, and using the XB to communicate wirelessly. 2 experiments are mainly conducted. The first one is validation of the effectiveness of using the food-based walking data to identify the person. We used the walking dataset with totally 17 sensor positions of the whole body. Each position-based acceleration is tested, and we found that the closer to the leg, the higher accuracy is. So, the food-based personal identification is possible. After the sleeper-based system has been demonstrated to successfully identify the person, we conducted the second experiment to assess the different sensor number and positions. We recruited 5 people and collected their walking data. With totally 6 sensors used, the system can achieve the 95% accuracy. From the result, the inner front position-based data can achieve the highest accuracy. As only one sensor's accuracy is not high enough, we increased the number of sensors. With 2 sensors used, the outer front, inner back are best position, and when 3 sensors applied, the inner front, heel, and outer back are optimal positions. We also tested different frequency components' impact on final accuracy. With found optimal sensor positions, the frequency range is continuously reduced and used to train the classifier for testing the accuracy. Finally, the result shows that the low frequency is significant, and combine 3 sensors, the better accuracy is expected. Some limitations are also in the work. For example, the person is supposed to register at the first, which is inconvenience, and only the straight line walking data is used to detect it. Such limitations can be improved in the future. Thank you very much.